Okay, guys, today we are going to build on our knowledge of solving a system of equations. So before, I would give you two equations, and let's say this is one equation, and you would have to find the equation of the line, and then I'm going to put in another equation. Let's see where they intersect. Okay, and so we have two equations here, and we have two lines essentially, and this is the intersection point, 0.75 and negative 2.5. And we would have to visually figure that out on our own, but the graph is not always going to be available for us to figure out the solution. And so today what we are going to learn is how to do it algebraically without this graph here. Okay, and I'm going to hit pause and take us to the next screen. Okay, so today we're going to learn how to solve a system, how to solve a system of two linear equations. And we learned how to do it graphically last week. And there's two different ways that you can do it. You could do what's called the substitution method, or we can do what I consider my own personal favorite and how I would do it almost every single time myself. And we're going to learn how to use what's called the elimination method. Okay. And before we get into any examples, I want us to think about what it means to eliminate. We see this word in the word elimination, we see this word eliminate. And eliminate in mathematics terms, we want to get rid of something. And typically when we get rid of something, that means we zero something out. So if I've got two variables here, 2x and 2x, and let's put this is positive 2x, and let's have a negative 2x. If I was to add these two together here, I would get 0x, and essentially I'm eliminating a variable. And the same would go if, let's say, if I have negative 3y and positive 3y right here. If I was to add these two together, I would get 0y. Okay, so we're going to use this idea of eliminating a variable. And it's important to note here, and I'm gonna circle some things here. It's important to note that the coefficients of these x terms, they're the same number, but the signs are different. All right, this is going to become very handy. I know this looks super obvious now, but I'm pointing it out so when the problems do get a little bit harder, a little bit more complicated, it sticks in the back of your head. The numbers, the coefficients have to be the same, but the signs have to be different in order to eliminate the variable. So let's keep this in mind when we are going through these problems. Ask yourself, are the numbers the same and are the signs different? Okay? And we're going to go to the next video, video number 2, and we'll go through a couple of examples.